Thank you everyone for joining us today. This is the first session in the Conversation with Colleagues series for 2019, which is being hosted by the TRB Bicycle and Pedestrian Data Subcommittee. These sessions take place roughly every fourth Tuesday of every other month and are focused around challenges in bicycle and pedestrian traffic monitoring. Today's session will focus specifically on bicycle and pedestrian crate rash analyses. My name is Nathan Hicks, and I'm a transportation planner at CDM Smith in our Miami office, and I will be moderating today's session. Our two speakers today are Shawn Turner, who is a senior research engineer from the Texas A&M Transportation Institute, and Huyen Lee, who is a PhD candidate at Virginia Tech. Now I'm going to go over a couple of ground rules here quickly before I turn it over to the both of them. As in previous sessions, the aim for this series is to be a bit more conversational overall. The hope is that as the discussion progresses between everyone, we can ask the speakers questions as well as each other. So if you do have a question, go ahead and type it into the chat area on the right, so that way we can go and answer the questions after each of the speaker sessions. I'll also go ahead and mention, as you're joining the session today, go ahead and please put yourself on mute. I don't believe it automatically mutes you whenever you join. So in order to potentially mitigate any background noise, please go ahead and do that at that time. Thank you. So following today's webinar, we're also going to be providing a summary. So any links or references that are specifically made in the webinar itself, as well as a recording, will be sent out to everyone. And I also do want to just thank Shawn Turner again for assisting us today in setting up the webinar and providing the access. We do appreciate that. So as I was mentioning, today's topic is specifically focusing on bicycle and pedestrian crash rate analyses, measuring and estimating exposure for safety analysis. The goals for today are to introduce and review the FHWA Guide for Scalable Risk Assessment Methods for Pedestrians and Bicyclists, which Shawn will be going over here in a few minutes. We also want to look and showcase a specific method from that guidebook and how it can be applied in research, and Huyen Lee will be speaking on that. So, without further ado, I will go ahead and turn it over to Shawn. Take it away.
Okay, thank you, Nathan. Hopefully my slide's going to pop up soon. I don't know if everyone else heard a little bit of choppiness as Nathan started. Can I just get a quick check on sound? Am I coming across clearly, or does it sound choppy?
I can hear you just fine.
Perfect, okay. The other thing I'll mention is, Nathan, were we going to do questions at the end? Or
the questions will be essentially at the end of your portion and at the end of Huyen's.
Okay, good.
So if you have questions, please go ahead and leave them in the chat, and we'll address them. We'll address them at the end.
Good, good. So glad that y'all could join us, and I'm going to give a really brief summary of this. We have a longer overview webinar that's on Federal Highway's website, but I just wanted to give a real quick sketch of this. And so I guess this is a project, Scalable Risk Assessment Methods, that we did for Federal Highway's Office of Safety. And I think it gives a good framework. It's basically, I guess the best way that I would describe this is it's a roadmap. There are multiple paths through that roadmap depending upon where you want to get to. And one of the biggest determinants about where you want to get to is the scale that you're trying to do risk assessment or that you're trying to do safety analysis. So you'll hear me talking about scale quite a bit. So these are the 8 steps in the framework. As you can see, right up at the top is the really important stuff, like figuring out where you want to go. Is basically, step 1, determining uses, and then what scale do those uses require. That those determinations, those decisions that you make in steps 1 and 2 really sort of set the parameters and help make those decisions in later steps a lot easier in terms of, for example, what risk definition are you planning to use or should you use, and how should you estimate exposure? There's more than one way to do it based on the scale of the analysis that you're looking at. So what we did, and I'm going to have a hyperlink to a much more detailed guide, but I'm just doing very, very highlights, 30,000 feet. So what we did was we outlined some of the most common uses of risk values. You see 6 of the most common uses here. These aren't the only ones, but these are probably the most common ones that we saw in use by practitioners. And so basically trying to figure out, well, okay, I want to do risk assessment. What am I going to do with those risk values once I have them? How am I going to use them? And so thinking about that, again, helps make the decisions and some of the other parameters a lot easier. One of those most important ones, because it is called scalable risk, is the scale. In other words, how granular do you need to make your risk assessment? How granular do you need to calculate risk, and therefore how granular do you need to calculate or estimate exposure? There's 2 basic groupings. You're either doing this facility specific, so you're either doing this at a point, that could be a crosswalk, that could be a combination of crosswalks, or you're doing it for a segment or a combination of segments. Both of those are facility specific. The other possibilities are maybe you're doing things at a high level. Maybe you want to do this more at an area-wide. So maybe what you're really interested in are these larger geographic areas like census tracts, like traffic analysis zones. Or maybe if you're doing high-level performance measures, maybe what you're interested in is an MPO area or an entire state. And so both of those fall into area-wide. And again, depending upon the scale that you're interested in, that's going to point you down a particular path in terms of the methods that you use and the exposure estimation tools that you might use in your particular process. So I mentioned the uses in the first step. These are the same 6 uses. And so you can see that typically the first 2 are area-wide performance measures and network screening. If you're doing it area-based, those are area-wide. Whereas the last 4 of the most common 6 are really facility-specific. So that helps point you in a particular direction or a particular set of routes, or at least that narrows down the possibilities that you can use. The next step is we'll figure out, how do we want to quantify, or what capabilities do we have, what can we quantify in terms of the risk definition. The title of this webinar, can everyone check that their phone is muted? I'm hearing some background sounds. And Nathan, you might look and see if you can see where the sound is coming from. If it doesn't,
I have been looking. I'm sorry.
No, that's all right.
I can't seem to pinpoint it.
That's fine. So the first is observed crash rate. I mean, that's the most common, but there are some limitations with observed crashes, particularly if you go to a very granular level for shorter periods of time. And so the Highway Safety Manual has introduced this notion of expected crashes and being able to essentially do statistical modeling of crash probabilities. Well, guess what? One of the biggest inputs to expected crashes is exposure, right? And so even if you're not putting exposure in the denominator of an observed crash rate, if you use the second definition of risk, you're probably going to need to estimate exposure as a way to be able to predict those expected crashes. The third is kind of it's additional risk indicators or surrogate risk indicators. It's what I would maybe call the data poor option. It's where you want to quantify risk, but maybe you don't have the capability or the resources to do expected crashes, and you can't necessarily measure exposure everywhere, and so you essentially look at what are the other risk factors that lead to crashes, and you quantify those risk factors. Maybe it's from a readily available statewide roadway inventory database or something like that. So that sets you down a particular path, and then it's a matter of selecting the exposure measures. Well, part of these, there's a number of paths through this framework. The path or the exposure measure that you choose, again, I think really ties back to what scale are you working at? Are you looking at the point level? Are you doing this for particular crosswalks or segments? Or are you doing this for an entire network or an entire region? And so that points you towards a particular exposure measure that you might use in your risk. And then this is ultimately, I think, this is what it boils down to. In the end, if you want to do safety analysis and you need exposure, you're going to get that exposure typically from one of three possible sources. Site counts, which we've talked about a lot in previous webinars, demand estimation models, and we're going to hear from Huyen here shortly about a specific type of demand estimation model called direct demand. That's probably the simplest. Those are both facility specific if you want to get exposure on a specific facility. But then if you only need area-wide, if you don't need exposure on specific roads, specific intersections or crosswalks, then it's possible that you could use travel surveys. And so our guide takes you through that process about, okay, which of those three methods is best depending upon the geographic scale, and then points you essentially to a number of other resources that have already been developed, really, that go into more detail about either site counts, demand estimation models, or travel surveys.
Hey, Shawn.
Sure.
Hi, sorry to interrupt. I did find a few of the users. Actually, are you able to mute everybody at the same time?
I don't know that I can, but I can try it. Whoops. Go ahead, Nathan.
Sorry about that. I just noticed the Sibel, if you're able to hear us, if you can mute yourself, that would be much appreciated.
Okay.
I believe they're muted now. All right. Thank you so much.
Yeah, no problem. And so I was talking about direct demand models. This is one of the most common demand estimation models. Huyen is going to talk about it next. She's been doing some work in that at Virginia Tech. And it's one of the most common because it relies on readily available data that can be gathered in a fairly simple statistical model. And so that's been used in a lot of different places. But ultimately, that demand estimation requires site counts. And she's going to talk a little bit more about how you develop direct demand models. The third part, or the third method for exposure at area-wide is travel surveys. And so in our FHWA project, we developed this pretty simple spreadsheet tool that basically takes and essentially does a mashup of the two national travel surveys, because both of those national travel surveys have limitations if you apply those at too granular of a scale, as well as one of the surveys, the American Community Survey, really only captures the primary commute to work mode, whereas the NHTS captures all types of trip purposes. And so we basically combine those two in order to estimate total biking and walking exposure at state and MPO areas. And so that's in a spreadsheet tool that we've made available. The final steps in our framework is essentially pulling it all together, taking the detailed information you have from exposure and pulling that together with the other required data and then calculating the risk values. I'm going to wrap up here. These are, we'll make the slides and these hyperlinks will be made available, but this is the guide. Again, this goes into a lot more detail, and we also have this spreadsheet tool that's available if you're looking for exposure estimates at a higher level, statewide or MPO area. And then we've got a fairly detailed synthesis that we did earlier in the project from which we developed this framework that I just talked about. If anyone's interested, and interested more than just maybe a simple question or two, TTI is providing technical assistance through May of next year, and all you got to do is contact me. Thank you.
Great, thank you, Shawn. Currently looking in the chat, and I don't see any questions. If you do have questions, there is an area to leave them. If you think of them later on, we can go through and answer them later as well. So at the moment, we'll go ahead and turn it over to Huyen, and she will go through her portion of the presentation. So Huyen, there should be an area for you to go ahead and share your screen.
Thanks, Nathan.
Great,
Okay.
thanks. In the meantime, Shawn just posted on the side some links and additional information for the guidebook from FHWA, so feel free to check those out and look at them a little bit more.
Just want to make sure, are you guys looking at my slides right now, or
We can see your slides, yes.
Okay, great. Thanks.
Yep.
And let's wrap it really quick. Okay, thanks for having me here today. I'm Huyen. I've just finished my degree at Virginia Tech, and I'm working with Ralph Buehler and Steve Henke in this project, and Steve Henke was the PI. So I'm going to present our study on traffic count data and how we use that to explore spatial and temporal patterns of bicycling and walking. Unfortunately, the risk components vary little in my presentation. But more so, I'll be focusing on direct demand model, as Shawn has mentioned. So I would like to acknowledge the support from Krista Nordbeck and Ho Hagedorn, as well as the DRIC team who helped us a lot in acquiring data from the NBPDP project, and Bryce Johnson, who helped me compiling this database. I thank the staff from participating MSAs, and a lot of other staff also send me data along the way that we haven't had a chance to look at in these two studies, but we're looking at that in the future. So this talk will focus on two studies that we developed from the database based on 20 MSAs in 17 years. So in the first study, we looked at the spatial patterns, and the second study, we looked at the temporal patterns of cow data in 13 MSAs in 13 years. So the main takeaways from this presentation are that cow data from multiple cities could be used to predict the spatial patterns of non-motorized traffic, and that from our cow data, we saw higher rates of increasing in bicycling and walking as compared to the rates that we derive from other data sources, such as the NHTS or ACS. And finally, we think there's a high need for cow data better in quantity and quality to track the spatial and temporal patterns of bicycling and walking, and use that for better planning decision, including crash and safety. So traffic monitoring would, provide a lot of information to inform the desired health promoting cities. and help us identify locations to locate bike and ped facilities, to predict crash location and crash rates, as well as estimating exposure to air and noise pollution. So we all know that we have really good CAL data for vehicular traffic, but it's not the case for bike and ped. And there's a significant gap, which is a lack of standardized measure of non-motorized traffic across jurisdictions. So when we conducted this study in 2016-2017, I realized there's still very few jurisdictions that have bike ped CALs, and most of them have very small number of CAL locations in their jurisdictions. So there's a mixture of CALs in different patterns and different methods. So most of them are manual CALs, short period, maybe several days a year in the fall, and mostly focus on the peak period. And then there are a few other jurisdictions that use automated counters, so they have first resolution for their data, so 24 hours in multiple seasons. So there's still this lack of consistency in CAL, so it makes it really difficult to compare and have a good result. Now, previous studies using CAL data only focus on a single city, and therefore there's a lack of generalizability of the results. So in the first study, we focused on the spatial patterns of bicycling and walking. So we looked at 20 essays shown in this map, and our objectives are to the relationship between the built environment and active travel at the national scale. And more importantly, we would like to spatially predict bike and ped traffic where traffic counts are unavailable. So our approach is as follows. At first, we aggregated CAL data. So we had data from the NDP, National Bicycle Pedestrian Documentation Project. We also requested data from local agencies. So all these are raw data. We aggregated that, and it came with very different formats and different patterns in terms of time of day, time of year. So we focused on the most common type of CAL, which is 2-hour peak period CAL data, and we got about more than 6,400 locations over 17 years. Now, in the second step, we tabulated 36 predictors. So we have 12 buffer sizes around each of these CAL locations. So our buffer size ranges from 100 meters to 3,000 meters. And we looked at these number of buffer sizes to determine at which buffer size that predictor has the most predictive power in predicting bike ped traffic. So we used publicly available data from Tiger, from Smart Location Database, from ACS, and NOAA, and Google Earth. And there we derive a lot of data for land use, for transport network, weather, and social demographics. Now, in the third step, we used all of those output in the second step to put in our model as predictor. And we use stepwise linear regression models that in a forward procedure, so it selects the most relevant variable first and keep doing that for the second relevant variables and keep going until it saturates. Our model was specified in a way that it only selects only one buffer size per predictor. So the outcome variable here is 2-hour count for bike and then for ped. And because we have segment count versus intersection count, and we have morning peak period and afternoon peak period, so we have 8 models in total for bike and ped. So these are the first direct demand models that we are aware of at the national level. And because of our goal pattern in locations that we don't have counts, we perform cross-validation in 2 ways, and I'll focus on the city validation in the next slide. So the detailed result could be found in our articles here in Environmental Health Perspective. I'm happy to share that with you if you contact me later. But Most importantly, we found a number of important predictors, including water and green space, job concentration, university campus, network density, and very important for for bike traffic is bike facilities and other variables as well. This is consistent with what was found in the literature using self-report survey or CAL data for a single city. So it's good that it's consistent. And we found that our model performed from moderate to good performance. So in this piece of analysis, I show here on the vertical axis is the mean square error for the prediction. So what we did for city holdout cross-validation is that we developed our trained model based on data from 19 MSAs, set aside one MSA for testing, we call it a test set, and see how the model performance improved with this. We started to incrementally put more data from that 20th city back into the training set and see if we can improve the prediction power. And here's the model performance shows. When we set aside all the data from the 20th MSA and only train the model based on all the data from other 19 MSAs, we found that the error rate for bike is acceptable, but for pet is pretty high. But when we start to add 10% of the data from the 20th city back to the training set, we got much lower error rate, which means that it improved the predictive power of the model. And when we keep doing that for 25% and 50%, we got much better improvement in prediction. So what it means for practice, let's say if there's one city that doesn't have resources to collect their own CAL data, they can use our model on these 20 MSAs to build a model and then use that to predict bike and pet traffic patterns in their city. And that's okay, especially for bike, a little bit off for pet. But if only they can go out and collect a little bit more data and use that to train our model in addition to the data that we already had, the prediction power would improve a lot. So it can predict pretty well what's going on in that city. We also perform another piece of analysis where we produce this prediction surface map for bike and pet in Washington, D.C. and Minneapolis at every single street segment in the city. So for bike, on the left panel, you can see bike traffic really follows the bike network. It follows the facilities. For pet, it's following the density. So whenever have higher job concentration or higher residential areas, you see more pedestrians. So this map could be used for something that is, for example, exposure to crash. And you can check out this report. Actually, Greg Griffin at TTI is the PI of this project, and he produces really cool studies which called Street Noise Relationship to Bicycling Road User Safety. It's publicly available online. And in another piece of analysis, we use the same data set, and instead of relying on the ACS and census data and smart location database, we also look at other patterns such as points of interest from Google Places and Google Street View, and see whether this can complement and increase the predictive power of our model. And we use machine learning for this purpose. So we'll submit that soon. Hopefully it'll be out. I'm happy to share the result later. In the second study, we look at the temporal patterns of bicycling and walking. And here's the map of 13 MSAs selected for the study. Those cities had the longitudinal counts. And our objective is to look at the temporal trend. And it's similar to the previous study, except that we have smaller sample size because we only concentrate in cities that have multiple years of data. And we use a linear mixed effect model for this purpose. This is the first model that I'm aware of that estimates the bike and pet growth in multiple cities based on longitudinal data instead of cross-sectional. And we look at objective measure data, that is CAL data, instead of self-report data. And then at the end, we compare the trends for our model with the trends derived from the National Household Travel Survey and ACS data and see if there's any discrepancy in those sources. So briefly about what we found here for bike, we found that bike traffic increased by 2 to 6% per year, depending on the model, whether it's intersection or segment, morning or afternoon. We found that pet traffic increased by 2 to 3% per year. Now, when we compare this with self-report data, so ACS and NHTS in maroon and orange here, we found that both bicycle and pedestrian traffic, or bicycling and walking rate to be specific, from this self-report data are actually show much lower rate as compared to our model results shown in blue for both bike and pet, which means that maybe the self-report data really underestimate the bicycling and walking growth rates over the years. And if we need to, make better prediction, or if we plan for bicycling and walking growth demand in the future, probably we need more cow data for this purpose, in addition to self-report data that we already had. So, of course, there are a number of limitations in our studies, and we hope that in the future, with the help of local agencies and practitioners, we have better data to make better, to have more refined results and better decisions here. So most notably is the site selection bias and city bias. So we still have lack of data from certain regions in the U.S. for the study, so it's less generalizable. In the future, we hope to have, cow site randomly selected that cover multiple locations in the city, as well as cover multiple cities in each region. And the third limitation is inconsistency in count methods. As I mentioned, we have manual counts and then we have automated counts. And most manual counts only have fall and peak period counts, which really reduce, our results a lot, limit our results. So in the future, we hope to have count from multiple sources, so we can compare cow data from manual cows and automated cows, but really aim for automated cows that cover 24 hours and multiple seasons and time of week. And in this study, we still use number of jobs as proxy for land use, and it's not varying over the years. So what we are doing now is using Google points of interest and Google Street View. Hopefully can capture better in terms of land use, but really it's no longer free, and I don't think it's really a better option for practice. So I hope to have refined land use data, and we can use that at a local level and incorporate that into the national model. And last but not least, there's still many missing predictors at the national level, and hopefully we have more information on AADT for vehicular traffic and speed limit, as well as other variables. So just emphasize again the importance of cow data. We need that to benchmark and to track the progress in planning for bicycling and walking, and to locate facilities, as well as to assess economic, equity, and environmental health in terms of safety, noise, air pollution, and mental health. So with that, really cow data matters. We need that to predict the spatial patterns, to track the rate, and we really need more and better cow data. So thank you very much, and I'm happy to answer any questions. Feel free to send me an email, and we welcome collaboration, and if you have data to share, I really appreciate it. Thank you.
Great, thank you so much, Huyen. We do have a few questions here. One is from Josh Roll. I will actually go ahead and share my screen now. So give me 1 second. Oh, unfortunately, that cancels me out. I'll leave it as a blank screen for now, then I'll share my screen in a moment. question is from Josh Rowe regarding the 20-city analysis that you were mentioning, Huyen. Have you compared network-wide estimates of the bike and ped activity BMT and PMT with the SCRAM estimates or other estimates from local sources?
Sure. I'm just wondering, could you explain what SCRAM is?
Yeah, I'll take that. SCRAM is an acronym that I tried not to use too much because I don't like acronyms, but it's for scalable risk. It's essentially the estimates, the MPO and the statewide estimates that we have from our Scalable Risk project that were developed by combining ACS and NHTS. Basically, Josh is asking, have y'all compared anything from your estimates from your direct demand models to another source as a way to say, hey, we think we're close to how we're measuring it in travel surveys, for example?
Thanks, Shawn. Unfortunately, we haven't did anything like that, but it seems like a really interesting point. I'll look more into that. This term is new to me too, so it's definitely something for my homework. But thanks for that comment.
Okay, we have another question actually from Thomas Gotchi. I apologize if I butchered your last name. He asked, could you elaborate a bit more about what suggests that NHTS underestimates versus the possibility that the count may be overestimating?
Sure. I think that's a good question. For NHTS, there's only 1 day travel diary, so I think there's a lot of I wouldn't say room for error, but it's 1 day travel diary. So and also it's a report survey. It's been shown that people might miss trips and they may underestimated number of trips, especially short trips for bicycling and walking. So that's something that we think might relate it to why we have this discrepancy between CAUT data and NHTS. Yes, I also I might suspect that there's also overestimate from CAUT data as well, especially when a person bike back and forth, or especially when we're looking at both AM and PM peak periods, so we might double count. But when we plan for infrastructure, for example, and this is the aim for our study, we need to count the number of people out there really use that piece of infrastructure. And so not just the number of people, but also the frequency of use. So in terms of planning, I think CAUT data is more relevant, to my opinion. And feel free to disagree with that.
Okay. We have one more question from Glenn Corey. Regarding the comparison between your sample growth rates and other national survey growth rates, does that just reflect that maybe the sample cities have invested more in bicycle and pedestrian infrastructure than the national average?
Great question. Actually, we received similar questions from the reviewers when we submitted this article. So we did the similar comparison from our CAUT data from this 13 MSAs with ACS data for these 13 MSAs as well. So it's not just the national, but also specifically to those participating MSAs. And we still found the same thing, the same patterns that really CAUT data show higher trends compared to that. But for NHTS, unfortunately, we cannot just separate data from this particular MSAs because we don't have that information, geographical information in the NHTS. Thanks.
Okay. Shawn, I saw that you were wanting to elaborate a little bit. Shawn, are you there? Well, in the meantime, there was another question from Josh Roll. Are there any states or MPOs using the NHTS/ACS derived measures or activity in official performance monitoring?
Is that for me or for Shawn? Yeah.
For Shawn.
Shawn.
No, yes, I think you are muted, Shawn. Let's see. Perhaps you could try your audio again, Shawn, and reconnect. Or change your audio source.
I'm not sure. Can anyone ask questions? Chime in here.
Of course, yes.
This is Thomas. Okay. So maybe I'll try to elaborate on my question in case Shawn doesn't come through.
Okay.
So I think the interesting aspect there is that these trends over the year discrepancies are quite tricky to explain. We would think that a population-based travel survey should, be the gold standard and capture everyone and capture the growth across the years, at least in theory. And then with the count data, right, we can get a little bit uncomfortable because these counters have not been placed in random locations, have not been installed by random cities. Glenn was pointing to this point. But on the other hand, of course, we know that the NHTS has massive limitation as well in even capturing these rare modes. But we've seen a similar pattern in Switzerland as well. So I think this is going to be, the more count data we have, it's going to become more relevant to be able to align these two data sources and correct for maybe what our bias is in probably both methods. So I wouldn't rush too quickly to a conclusion that one overestimates or the other one underestimates. It's probably a little bit of both.
Yeah. Can y'all hear me now?
Yes.
Yes, we can hear you.
Perfect. My headset was malfunctioning. I just unplugged it and connected by phone. So
Perfect.
I'm gonna ask. I unmuted Krista about a minute or two ago because I was going to have her talk about her Washington State study. But I think that basically what you just said is the point. Is that I think I can't point to specific studies, but NHTS typically undersamples, or there's anecdotal evidence to suggest that it undersamples, and in particular recreational trips, just because of the nature of that type of survey. And that and direct demand estimation or other demand estimation models that are calibrated against count data, well, that count data is, like you said, Tomas, it's a convenient sample, and we usually put counters where it's cost effective to actually put out counters, which is where the counts are typically higher than average. And I think, Krista, am I characterizing that correctly? Is that basically what you concluded from your effort in Washington State?
Yes, and a lot of these data from the National Bike Pedestrian Documentation Project are collected, wherever the jurisdiction wants to collect data, and that's often by volunteers who they don't want to put in a place where there's no one walking and bicycling, so there's an automatic bias there towards places where people are actually walking and bicycling. So, absolutely.
Great.
And I think part of the challenge here, because we're actually, I had mentioned in the comments in the chat box, in my opinion, I think crowdsourcing is going to help. But part of the problem that we have is it's hard to know what the ground truth is. I mean, it's hard to measure. What's the expression? The number of angels on a pin. I mean, that's kind of what we're trying to do here when we talk about measuring walking at a citywide, countywide, region-wide, statewide scale. To be able, who has the most accurate measurement? Well, sometimes that's just hard to figure out in and of itself.
I'm hoping that more jurisdictions, this is Krista again, would go to sampling in a more scientific way, maybe try some random sampling and trying to encourage some jurisdictions to do that so that we can get away from some of those biases.
Shawn, I think there's a question for you from Josh.
There is.
Yeah. Okay. Yeah, I just noticed that. So I believe there is one or two state DOTs, if I recall correctly, that were asking questions about, and I think they ended up using the estimates in our NHTS/ACS derived. And they're using that in basically high-level performance reports. And that was really the genesis for that spreadsheet tool, was that, at some point in the future, it's not in there now, but the safety performance measure requirement from Federal Highway has states and MPOs to report the number of non-motorized fatalities and serious injuries. And there was discussion, I know whenever they were doing the rulemaking for that, about whether or not DOTs and MPOs could accurately estimate the exposure. So the exposure for non-motorized is not in the rule, but if enough states find the estimates in this tool to be of value, then it's possible that could be used in the future. But that's, I think that would be something that plays out through rulemaking or future transportation legislation.
All right, we have another question from Arthur. He was asking about random sampling and how that would look like for collecting count data. Are there resources within your presentation, Shawn, or Scram website that describes how to place surveyors or permanent counts in randomized locations on the bicycle and pedestrian network to achieve the random sampling?
We would have pointed, I know we pointed to a table of resources, and I'm going to rattle off a few of those that folks may be familiar with or they may not. But so one of them is the Federal Highway Traffic Monitoring Guide. The other is NCHRP Report 797. But and others, this is where the conversation part comes in handy. I think the current guidance is to not just randomly select count locations, because what you end up with, you could essentially end up putting a $10,000 counter somewhere where there's nobody biking or walking. And so all of the guidance that's in Traffic Monitoring Guide and other national reports essentially says, here's some site selection criteria. Pick sites according to these criteria rather than doing a random sample. I mean, you would do a random sample if you were doing some type of a model development. But again, there's always that question of you're using data collection resources and you're counting 1, 2 pedestrians a day or 1 or 2 bikes a day. What's other people
Can I clarify what I was recommending, Shawn? So I'm not recommending that permanent count sites be selected randomly. I don't recommend that. I agree with what you're saying, that we need to be very careful about where the permanent count sites are located. But a lot of the data that we've been talking about that Huyen is looking at was the short duration count sites, and these are just sites where people go out and they grab some data for 2 hours or 12 hours, like she said. And those are the sites that I think would be best if we could randomize, do some kind of random sampling for.
Thanks, Krista.
Go ahead.
I'd like to follow up on that. I think in our sample list, there's a number of locations that have very low traffic, which I think is pretty much random to me when we plot that on the map. Tucson, for example, there's a lot of sites that they have either 0 to less than 10 for 2 hours period. And a lot of that also use video counts. I'm not sure that could overcome, the cost and other things, because hopefully that could count ped and bike and something else together. So it's still cost effective.
I think one of the other points to make there is randomizing locations. It's important to make sure that it is still on the bike and ped network itself, and not in areas where you're just going to find a low amount of bicyclists or pedestrians themselves. So it's important to make sure you're noting on where, if you're looking at the network itself. But there was another question from. Oh, go ahead.
Yeah, well, I was just going to add, I was going to tie in a comment on that to the next question. And so I think it relates to crowdsourcing methods and randomness, because I think that essentially, if we can perfect our ability to get rid of some of, or to reduce some of the bias in crowdsourcing methods, and I'm talking about crowdsourcing beyond just sort of the active things like Strava or other tools where you got to start it and stop an app. But that would help us whenever we don't have to put people or even portable counters out at hundreds of possible locations at a city, where we can just take random samples of data that already exists. I think that will improve our ability to develop more accurate models that tend not to overestimate, because you're tending to count where there's more traffic. What do others think about that?
I agree.
With regards to randomization, I think it depends on how you integrate the data that you collected. If you model some network-wide distribution, I don't think it has to be perfectly randomized, and you can correct for the fact that, I don't know, how much more often or how much longer you've been counting on certain streets. But I think you have to develop a network-wide demand model. If you do simpler assessments of, I don't know, average levels of traffic or average trends of traffic, then ideally you basically have to have a randomized selection of locations and time slots. And you can probably get away with some correction factors that you say, okay, you still just go out there during peak hours and correct for that fact. But we understand that the peak hour, the daily patterns, temporal patterns, much better than the spatial patterns, right? If you collect in street A, B, or C, you have no correction factors that will tell you how much lower or higher the other street is versus that one. So I think if you just want to come up with crude averages across your count data, randomization is key. But I think there's more sophisticated modeling techniques that can integrate these data network-wide, and then probably it's not required that we have, a count of 6 cyclists an hour on every little neighborhood street. I think we can then extrapolate these kind of flows.
Great. Well, thank you, Thomas. I'm going through the questions and I don't see any others. Well, any other new ones, although I do see something from Josh. For safety analyses, should jurisdictions still consider 2-hour counts as an input either directly or through an activity estimation model? I suppose this would be for anybody.
This is Thomas again. I had a question in similar direction. So for safety analysis, like when do we deem a crash rate or some crash risk estimate as robust enough? And I think there's very few occasions where you can say, okay, I've estimated this on a facility based on, a few 2-hour counts and saying, okay, you have a robust enough exposure. And at the same time, you also need a robust enough estimate of these crashes that you're interested in. So I think just by the nature of the phenomenon, we're forced to move back to bigger areas or area-wide assessments for these crash rates, which in a way is probably a non-satisfactory answer to that question. But so we're building impact assessment tools where we want to provide users with basically pre-populated crash rates, and we're very hesitant to come up with a method that allows you to do this on a specific segment or an intersection, just because you will not be able to collect the necessary data on that spot, and we don't have the models that allow us to predict those based on the characteristics of that location. Not yet, but I think obviously we would want to have them. But if you do 2-hour counts, how many 2-hour counts do you have to do until you observe, let's say, even 30 crashes? Or ideally you would want to see 100 crashes so you can derive some more robust estimates. I think that's the first thing to look into.
Well, thank you, Thomas.
Surely somebody else wants to. Hopefully, somebody else wants to weigh in on the value of 2-hour counts. If you're trying to say something, you might check your mute to make sure you're unmuted.
Well, if no one else wants to say something, I can say something, but I wanted to give someone else a try.
Go ahead, Krista.
Okay. Well, obviously, the 2-hour counts are inherently just a very, very, very small sample of what's going on throughout the year. So if we're looking at crashes throughout the year and we're only looking at some peak hour in the summer or peak hour in some low, February, that would be horrible. I would not use data from winter. But it's still, when you're trying to represent what's going on throughout the year, there's a lot of error in doing that. And I've worked a lot on quantifying that, and I think we had like 60% error. And if you're trying to estimate the volume throughout the year, so definitely a hazard.
This is Bahar DaWG. I just wanted to add to what Krista said. Usually, like when we do safety analysis, we have to do it for a year. If you are able to, if your direct demand model is able to estimate the bicycle counts for annual average bicycle counts, I think you would probably be able to, but I'm not sure if with 2 hours of data you would be able to develop direct demand models that are so sophisticated. Yeah, I mean, it really depends on what kind of safety analysis you want to do.
Okay. So it sounds like the the time required is variable on the safety analysis, is what you're saying.
Yeah. I mean, for the crash analysis, we'll have to do, like when we're looking at safety performance functions, we're including annual average traffic. But I'm just concerned that you would be able to derive AADB, or annual average daily bicycle traffic, from 2-hour data.
Right. Okay.
But that's still a question. I think there is an ongoing NCHRP project which is trying to develop SPF for bike ped crashes. So you could also, like, if you are dividing your safety performance model into morning or nighttime, you might be able probably to use 2-hour crash data, count data.
Mm-hmm. Great. Well, thank you. There have been a number of comments that have come in here on the side. I'm sorry if I've been missing a few of them. Trying to scroll through and make sure that either we've addressed them or have mentioned them. There was one from Arthur again regarding randomized sampling for streets and different variables and how it has affected cycling volumes. In other words, he was saying cutting down streets, those which we need data from, and introducing randomization. So another take on the randomization of data and collecting data. And then he had a follow-up and then Glenn had a follow-up from one of his previous questions, saying you could be collecting bike and pedestrian counts at similar sites. You're collecting general traffic count data if you're using an outsourced video count system. Mentioned that they're counting all modes of movement in central city intersections during the same annual surveys. That is a good way to do it. You were able to collect a lot of good information by combining those two different efforts together. So hopefully other efforts like that will be able to be pursued by other cities or counties. And Glenn also has another comment here saying you have to remember that pedestrian and bicycle counts have different peaks, of course. So, and you might have to observe them at different times. Saying bikes have, your AM and PM commutes, and pedestrians sometimes will have lunchtime peaks in some urban areas. So, Shawn, were there any other comments or any other points you wanted to make specifically regarding your topic or your the FHWA Scalable Risk Assessment Guide?
No, not at this time.
Okay. Huyen, are there any other comments or questions? Anything else you'd like to mention?
None that I can think of.
Okay. Well, I don't see any other comments coming in at the moment, so if you bear with me 1 second, I'll go ahead and share this last slide here. Seeing no other comments and no other information, we'll go ahead and wrap up today's session. Thank you all for joining today. We really appreciate all the comments and questions. This was a great discussion, a great way to start off 2019. I'd like to thank, of course, again, Shawn for assisting us with the setup for today's webinar and also participating as a speaker. And, of course, to Huyen for providing some additional insights to today's topics. And, of course, to everybody for participating. It's great to see the discussions going back and forth between everyone. Our next conversation with colleagues session is to be determined. Likely will be sometime in July. We will figure out and determine the date specifically and send out some more information to you all soon. The topic will likely focus on standardizing and collecting data with local partners. So if there's anybody here that is on the session that has some information on that, or would like to speak a little bit about that, you can feel free to email us afterwards, so that way we could perhaps have you on as a speaker for the next session. And hopefully we will see you all at the APBP conference in August in Portland. And with that, we will go ahead and close out today's session. Thank you all for joining us today, and I hope you have a good rest of your week.